Hello kids, in today's class, let's do the last exercise of this chapter, exercise 12. Okay, so the first question is, the following figures are drawn on a squared paper. Count the number of squares enclosed by each figure and find its area, taking the area of each square as 1 centimeter square. So what they have done here is, they have taken the square, each square as 1 centimeter square here. So let's draw it here. This is one square, kids. Sorry, this is one. This is second, third, fourth, fifth, sixth, 7, 8, 9, 10, 11, 12. So there are total 12 squares here. So I can write this area is equal to 12 centimeter square. Okay. And similarly, we can find out for this also. This is 1 square, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11, 12, 13, 14, 15, 16, 17 and 18. So in total, we have 18 full squares here. Okay, so the area will be 18 centimeter squares. And similarly, kids, let us do this also. We will see the full squares first. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 0.5. So this is 14.5 centimeter square. Okay, and similarly, you can pick the other questions. They are very easy. Second question we have, find the area of the figures given below using a sheet of squared paper. So kids, what you have to do here is, you have to take a square, this graph paper, overlap it, and on that just draw the figure by overlapping. You can trace it and then find the number of squares which are there in these enclosed figures. Okay, so this I am marking as a homework, and the other parts also which we have done not done above are marked as homework for you. They are very easy. Coming to question number 3, and the similar question we have done in the Ganita Prakash, where we have learned that the full squares are taken as 1, the half squares are taken as half, and the less than half are taken as, we are ignoring them. More than half are also taken as 1. Okay, so let me do this first. Okay, this is half square. I'm writing the number of halves. This is half plus 1 and plus half. 1 and half. Next, we have this half and this one, 1 and half. So that means we have 2 halves and 2 full squares. Coming down, 1 half, 1 full. So 1 half and 1 full. Let us count the full first. 1, 2, 3 and 4. We have 4 full, and now let's add half. 1 half, 2 half, 3 half, 4 half and 5 half. So I can say we have 5 halves. 5 by 2 plus 4, which will be equal to 4 into 2 is 8 plus 5, 13. 13 by 2. And if you divide this, this will be equivalent to 6.5. This is 6.5. If we are taking this as in centimeter, so this is square centimeter. If we are taking 1 square as centimeter square. Okay, so this is how we have to do this question, kid. And next, let us do this one, the last part. Okay, so this is second part. I'm doing the fourth part here, this one. 1 half plus 1 plus half. So this is half plus 1 plus half. Then coming down, half, 1, 1, 1. So that is half plus 1 plus 1 plus 1. Coming down again, this is 2 halves. Okay, 2 halves. Coming down again, 1, 2, half. So this is 1, 2, half. And again, we have 2 halves. So half and half. Now let's add them. 1, 2, 3, 4, 5 and 6. 6 plus how many halves? 1, 2, 3, 4, 5, 6, 7, 8 halves. So 8 halves will give us 6 plus, let us solve this, 2 into 1 and 4. 6 plus 4, that is 10 square centimeters. Okay, and similarly you can do the rest of the questions. These two are homework for you. Now let us go to question number 4. What it says is, right, this was the fourth part, sorry, I'm writing question number 4, this one here. How many different rectangles can be drawn whose length and width are a whole number of units such that area of a rectangle is 30 centimeter? So we know that area is 30 centimeter square given to us. Also we know that we are talking of a rectangle, so area is length into breadth. Now what it is saying is that what are the different combinations of length and breadth where both are the whole numbers, not the decimals, which when multiplied together give us the area is 30. Okay, so let's begin this. Let's start and see what are the different factors of 30 starting from 2. So we can take this as 2 into 15, 3 into 10, this will also give us 30. Then after 2, 3, we have 4. So if we see for 4, what we have here as 4 is not divisible, so we cannot take it as in decimals. 5. So with 5, we have 5 into 6. With 6, we have 6 into 5, which is also again same. With 7, it is not possible. 8, not possible. With 9 also, it is not possible. 10, we have already covered. 15, we have already covered. And the last one we have as 1 into 30. So this I am removing because this is repeated. These two are same. Okay. So these are the different combinations possible here. Now, which rectangle has a greatest perimeter? So in order to find the perimeter, what we have to do? Perimeter, the formula is twice of length plus breadth. So let us find out the perimeters of all these here. 15 plus 2 is 17. 17 into 2 is 34 here. In this case, the perimeter will be 34. In the next case, what we have is 30 plus 3 plus 10 is 13 into 2 is 26. Next, 5 plus 6 is 11 into 2, 22. And the last one is 30 plus 1 is 31 into 2 is equal to 62. So if you see here, which rectangle has the greatest perimeter? So this rectangle, where this is 1 and this, sorry, easy. Just moving it a bit. So the rectangle where the length is 30 and the width is 1, it has the greatest perimeter of 62 centimeters. Second part, which has the least parameter. So the least parameter is this one, 22. So that means in this case, what we have is the length will be 6 and the width is 5. Okay. So in this case, the perimeter is 22 lowest. Here the perimeter is 62 highest. Okay. So these questions are important, kids. We have similar questions. We have done similar 2 questions in Ganita Prakash also. Okay. So practice these questions. Now, next question is, look at the following figure made using 11 square units. So here the number of squares are 11. Each square is of 1 square unit of area. So the total is 11 unit squares. Now, without calculating, find out how the perimeter of the figure will be affected in the following scenarios. So what we are doing here is we are doing certain changes, and without calculating we have to see that how the new unit is changing the perimeter. So the first scenario is what will happen, find out how the perimeter will change if the new square is added at position 1. This is position 1. So let us try to add one square here. Okay. So when I am adding one square here, so this side, the inner side, this inner side is not covered, means this will not be counted. This will be same here and this is also gone. So that means there will be decrease in parameter. Why? Because these two sides we will be losing these two sides. When we are adding the square here, it is going to introduce one side which will be equivalent to this, but these two sides will be removed. So the area will decrease. Sorry, the perimeter will decrease. Next is add the position marked as 2. So if we add here, what will happen? So if we are adding here, we can very well see two new sides are added. So the perimeter is going to add, that is increase. This will increase the perimeter. So kids, I understand that you are getting it. Now the third one is if it is marked at the position 3. So this is the position 3. If we are adding 3 new sides are added here. So this is also going to increase. The last one is the fourth one. So if we are adding here in the fourth one, 3 new sides are added. So this is also going to increase here. Increase here also. Now, can you guess what will be the change in the perimeter of the figure if we cross out square is removed? Now, let me go to the original shape first, and what we are going to see here is that if we remove this square, if we are removing this square, this one, so it will be, this figure will now be something like this. So this is removed, right? But then this will be considered, which was not considered earlier. This is equivalent to this one, and this is also going to considered. So that means this is going to increase in the perimeter. Okay. Now, kids, the next two question number 6 and question number 7 and 8. The next three questions are same which were there in the Ganit Prakash. So I am leaving these questions, these three questions, but you can practice them again because we have already covered them in Ganit Prakash. Okay. So this brings us to the end of this exercise and end of this chapter also from R.S. Aggarwal. So in the next class now, I will see you with the new chapter. And if you have any confusion, you can always email me. Thank you.